Okay, we're continuing on. So on number 55 to 60, directions. In the value of the Taylor series at x equals 0, the function f of x at a particular point, that's what each of those would be. It states what function and what point is it. So basically, this table I'm providing on your test, you're trying to match, and if you really look at this, this really says the series n equal to infinity, negative 1 to the n minus 1. Basically, it's right there. Times, and you notice that those two are raised to the n power. So can't I say that's 2/3 to the n power all over n? Now, if the first term is 2/3, do you see that this must start at 1, not at 0? And now all what I'm doing, I'm trying to match this with one of those, and this is provided on the exam, this table. Well, I am looking for something that has an n in the denominator, negative 1 raised to the n minus 1, and an x to the n. So when I'm glancing at those, I notice x to the n is right there, but there's nothing in the denominator. Same with this. This is n factorial, doesn't match, and it's not alternating. 2n plus 1 factorial, not going to do it. No factorial. This is a candidate, and that's about it, actually. And if you look at that, that matches. And that is natural log of what? Of x. Do you see where x is? So that's natural log of 1 plus that. So this is the natural log of 1 plus whatever that x is. And that turns out to be natural log of 5/3. So here it's like, matching pairs. Here, this is the series n equal to infinity. And I notice those are raised to the same power. So it's negative 1 to the n. And they're raising pi over 3 to the 2n all over 2n factorial. So the game begins by trying to identify which of those. And that's what I'm going to plug in raised to the 2n. And here n begins at what? Do you see at 0 because the first term is a 1? Well, let's see. Which of those happen to have a 2n factorial? It can be this. It can be this. Nope. Nope. 2n factorial, that's a candidate. Does it have negative 1 to the n? Yes. So what's taking the place of x? What's taking the place of x is pi over 3. And what did we see this to be? This is the cosine of whatever this is. You take the cosine of it. Well, that indicates this is actually the cosine of pi over 3. And what's the cosine of pi over 3? That's 1/2. So that's the first set of problems. The next set of problems, I'm going to have two of those. It says find the Taylor series at 0, which means find. So I can't use the table, right? I can't say, well, look, I know what the sign is, and that's not going to happen. You don't get credit for that. If it says use power series, you could use the table. If it says find, you're going to say that's f of 0 plus f prime of 0, x to the 1 over 1 factorial, plus f double prime of 0, x squared over 2 factorial, plus triple prime of 0, x cubed over 3 factorial. We know we need to list a bit of those because they're going to cancel out at 0, right? Sine and cosine. So maybe 6 or 7 of those. Otherwise, normally I need 3 or 4. And the list goes on. So I need to know where those are. I need to know f is the sine of 2x over 3. And if I evaluate that at x equals 0, that's a 0. F prime is 2/3 the cosine of 2x over 3. At 0, that's 2/3. F double prime is negative 2/3 squared the sine of 2x over 3. At 0, I'll get a 0. F triple prime, that is negative 2/3 cubed. And I wouldn't multiply those because I want to figure out the pattern. Cosine of 2x over 3. At 0, that's negative 2/3 cubed. The fourth derivative of x, that doesn't look good. The fourth derivative is going to be positive 2/3 to the 4th, the sine of 2x over 3. At 0, that's 0, and maybe the 5th derivative. That is 2/3 to the 5th power, the cosine of 2x over 3, and at 0, that is 2/3 to the 5th. That makes this a 0 plus 2/3 x to the 1 over 1 factorial plus 0x squared over 2 factorial minus 2/3 cubed x to the 3rd over 3 factorial plus 0x to the 4th over 4 factorial plus 2/3 to the 5th x to the 5th over 5 factorial, and the list goes on. And if I look at these terms, I notice there's 2/3 to the 1 x to the 1 over 1 factorial minus 2/3 cubed over 3 factorial x cubed plus 2/3 to the 5th over 5 factorial x to the 5th minus, and the list goes on. That would equal the series n equal to infinity. And let's see. If we tie everything to x, that's why we always want x. 1, 3, 5, you could use arithmetic, or you could say that's 2n minus 1 or 2n plus 1. Even is 2n, odd is 2n plus 1 or 2n minus 1. Now, I noticed that whatever this is, whatever this power is, this denominator is factorial. And I have a 2/3 raised to that power as well. And it's alternating. Let's try. If I let n equal 3, this saying n equal 3 negative 2/3, 3 in there, that's 6, that's to the 5th power, x to the 5th power over 5 factorial, and if I match it with this, do you notice that this is positive and this is negative? Minus 1 or plus 1 will do. And where can I start? Do you see I can only start at 1 because the first term is x to the 1? And that would be my answer. The next set of problems says, find the first 4 non-zero terms centered at a. Remember, we did something like that. If I take f of x, which is 1 over 1 minus x. By the way, this is going to be a homework on the previous set of problems. Just pay attention to that. You could write it as 1 minus x to the negative 1. You're going to say that is centered at 2. That's going to be f of 2. That's one term. F prime of 2 times x minus 2 to the 1 over 1 factorial. That's 2 terms. You only want 4 terms, so 2 more to go. Plus f double prime at 2 times x minus 2 squared over 2 factorial plus f triple prime at 2 times x minus 2 cubed over 3 factorial, and the list goes on, but that's all we want. So I need f, which is 1 minus x to the negative 1, evaluated at 2. That would be 1 over negative 1, which is negative 1. I'm going to take f prime, which is negative 1 minus x to the negative 2 times negative 1, evaluated at 2. That would be 1 over negative 1, but it is squared, so that's a 1. F double prime, you bring the power down, subtract 1 from the power, times negative 1, so that's positive. When you plug in 2, you're going to get 2 over negative 1 cubed, which is negative 2, and one more. Triple prime of x, that is negative 2 times 3 times 1 minus x to the negative 4 times negative 1, so that's positive. That's going to be 2 times 3 over negative 1 to the 4th, which is 2 times 3. So basically, this is f of 2 plus 1 times x minus 2 over 1 factorial minus 2 times x minus 2 squared over 2 factorial plus 2 times 3 x minus 2 cubed over 3 factorial minus, the list goes on, that's negative 1 plus x minus 2 minus, those cancel out, x minus 2 squared plus, those cancel out, x minus 2 cubed. And there it is. There are other ways I could do this, but we're just following directions. On the next problem, I want to take this limit, and I went to page 654, and this table is provided. So if I throw 0 in, I get sine of 0 over 0 minus 1 over 0. This is really a big mess. So it says use power series. Use, I don't have to derive. This is going to be the limit as h approaches 0. I do have to split this up, however. This is h squared. Well, this right here is this right here. I just need the expanded form. Sine of h is going to yield h minus h cubed over 3 factorial plus h to the 5th over 5 factorial minus h to the 7 over 7 factorial, and the list goes on. And this is all divided by h right there, minus the cosine of h. The cosine of h is right there. That is 1 minus h squared over 2 factorial plus h to the 4 over 4 factorial minus h to the 6 over 6 factorial, and the list goes on. So if I apply this, where is it? If I apply this division, if I divide each of those by h over h is a 1 minus h squared over 3 factorial plus h to the 4 over 5 factorial minus h to the 6 over 7 factorial, and the list goes on. If I distribute this negative n, that's going to be minus 1 plus h squared over 2 factorial minus h to the 4 over 4 factorial minus h to the 6, and the list goes on. Now, I notice that this one and that negative 1 cancel out. This is actually the limit as h approaches 0. And this is negative h squared over 3 factorial plus h squared over 2 factorial plus h to the 4 over 5 factorial minus h to the 4 over 4 factorial minus h to the 6 over 7 factorial minus h to the 6 over 6 factorial. I think I missed a sign somewhere. That's a minus, that's a plus. That should be a plus right there. Okay, now we're good. And the list goes on those, all divided by h squared. So now, if I divide each of those by h squared, I could combine them, of course, but that's a lot of work. That'll leave me with negative 1 over 3 factorial plus 1 over 2 factorial. That is, I'm dividing each of those by h squared plus h squared over 5 factorial minus h squared over 4 factorial minus h to the 4th over 7 factorial plus h to the 4th over 6 factorial, and the list goes on. And now, if I replace h by 0, each of those will 0 out, and guess what? I would be left with negative 1 over 3 factorial plus 1 over 2 factorial. On a test, this is good enough, right? You want to match it with the back of the book. That's negative 1 over 3 times 2, that's 6, plus 1/4. LCD is a 12. That is negative 2 plus 3, that is 1 over 12. And that's the limit, and that's pretty much it.